How dams produce energy. Dams shape the world around us. They reimagine vast landscape by repurposing rivers, and they produce energy to millions of the homes across the globe. These monolithic civil engineering wonders have been around since the birth of the civilization, and today they are a vital source of the electricity. Globally, 60% of the world's electricity is produced through hydroelectric power plants, most of which are located inside, on, or near to the dams. At first glance, dams don't appear to have an energy producing power. To the casual onlooker, they are just large concrete or earthen structures that keep water from flooding areas downstream. However, dams, and more especially hydroelectric power plants, take advantage of one of Earth's most abundant resources: gravity. Hydroelectric power plants harness the potential energy created by the water that the dams holds back. They capture the energy of the water as it falls from high up behind a dam. This is done through the use of turbine generator, which harness the kinetic energy and transform it into mechanical energy. This mechanical energy is then converted into electrical energy with incredible efficiency. Modern hydropower plants can convert energy from water held by a dam into electricity with up to 95% efficiency, contrasted to the base fossil fuels power plants which operate around 50% efficiency. Dams and their accompanying hydroelectric power plants can range in size from a few feet high, used to power a few homes, to several hundred feet like the three George dams in China that can power entire cities. Now let's learn a little bit more about how these power plants works. Modern hydroelectric power plants include four main components. The number one is dam. Dams are used to create potential energy in water, allowing it to build up in great quantities at elevation. Dams are also a way for power plants to store energy and control flow. The second one is turbine. The turbine is the mechanical component that transforms the flow of water through a dam into mechanical energy. Turbines are like windmills, except the forces that spin them come from water rather than wind. Third one is generator. The generator takes the mechanical spinning energy from the turbine and uses it to generate electricity. Generators in hydropower plants work exactly the same as generators used in other situations. Fourth one is power transmission lines. These take the electricity from the dam and power plant all the way to the houses and other places that need it. Now let's start thinking about how much energy a dam can make. The ability of a dam to produce a given amount of electricity depends on a few factors: how far the water has to fall, how much waterfall is falling, and the efficiency of the turbines and generators. These three factors are significant when determining the output of the given dam. For example, further that water falls through a dam, the more power it has, gravity acts on the water at the top with an acceleration of 9.81. The further it has to fall, the faster the water moves when it hits the turbine. The power that water can produce is directly proportional to the height that it falls. Simply, 100 foot 30 meters dam has twice as much energy producing capability as a 50 foot 15 meters dam. The amount of the water falling also has a big impact on the energy producing capability of a dam, while the height of the waterfalls at a given moment impacts how much power it can produce. The amount of the water falling at the height impact how much power is actually produced. The amount of the water is often not something humans can control through, as it is dependent upon how much water is flowing into the lake the dam holds back. Dams and hydroelectric power plants can adjust flow. The turbines But at the end of the day, they only have as much water to the power plant with as it held in the dams. If dams and hydroelectric power plants operators ever wants to speed up or slow down how much electricity they are producing, they can change the flow rate of the water they are letting through. In this way, engineers often of dams as physical batteries storing a given amount of the water in a dam. Dam is essentially creating a battery of the water that can be used to generate electricity. Later on, lastly, the energy producing capabilities of the dam depends on how efficient their turbines and generators can be, given the hydroelectric power plants that have roughly 90% efficiency. These power plants are some of the most efficient out there. Now let's recap the basics. Dams are used to block up river and stream to create potential energy with the water by holding it in reservoir at the high elevation. The dam is then used to control the flow of that water into a hydroelectric power plants, which are often located inside or right next to the dams themselves. That water flows into the turbines, which is spun by the water. The spinning turbine then turns the generator, which transforms the spinning motion into the electricity energy. That electricity then carried through transmission lines to your houses. That's the end of this video. Thank you.